Okay, this is another episode of our Unwatched Videos channel from YouTube. Today we're going to do the comparison of a hollow block wall compared to a poured concrete wall. We're going to focus on this video on the materials cost because the poured concrete is cheaper on labor, but we're going to work on the materials. The method is we're going to figure out the volume of a wall. We're going to figure out the volume of that wall that is hollow blocks, and the remainder of that portion of the wall will be mortar, either between the blocks or filling the cores. The core should actually be filled with a small gravel and sand mixed with, rather than the mortar, but common practice is just dump extra mortar in it as you go. The rebar, the reason it's really pretty much a price wash is the hollow blocks have a horizontal rebar every 3 courses, and the vertical ones are every 3rd hole. Well, you skip a hole, and you have to overlap those pieces of bars by 16 bar diameters, so you lose that much off of every piece. And the length of the pieces they use is so that they can be standing on a scaffold and hoist the blocks up over it and lower it back down to where they're placing it. So with all that overlap, you lose an awful lot of bar. Also, the poured concrete wall does not have to have a column. The entire wall can be considered a beam or a column because it's steel reinforced and it's solid concrete, just like a column. Now, to make this as fair as I could think to make it, we went to standard practice on a hollow block construction of 12 feet of block before a column. There's 12 feet column on either side. For the comparison, we have a 12-foot long piece of hollow block, and then we have a column that's 16 inches wide. The thickness of the column is a 5-inch block plus 2 renders on either side, with a standard render, which is 3 centimeters to the side. Some people use less render, but just so we have a flush mounted column, the column thickness is 7.362 inches, 16 wide. And that is in addition to the 144 inches of hollow block. To figure out the inches of hollow block, let's see if we can shove some stuff around. This is our representation of a 5-inch hollow block. A normal block has got a thick flange side and a thin flange side. This one's just drawn the average cross-section in the middle of the block, same exact cubic inches, just easier on the computer to figure it. We have, oh no, not that one, this one. Here's our blocks put together in a wall. It's not showing the render so you can see the blocks, but this space here on where the column is wider than the blocks would be the render. So this piece of wall is 108 concrete blocks. We have another picture down here. Oh, I'm going to try to tilt this. You can see the render is the same thickness as the column on this top view, basically, of what we're doing. And you can tell I'm not trying to make any particular length video. I'm going as fast as I can. Okay. The height of this wall is also what the blocks come out to, 99.218 inches. That's because we had to pick a thickness up here. Looking at our block from the side, this is the end joint most blocks are pretty much pushed up tight, but there's blocks that are just pieces of blocks stuck in, and there's actually supposed to be a head joint. The better builders will leave a space, and then they throw mortar in from the top into these two half cavities, and the render fills the rest. So if you have if you put your blocks up the way you really should be putting them up, there'll be an actual head joint. The base joint down here is an average of the two finger type joint, 2 fingers wide joint, where the rebar course is, every third course, and a slightly thinner joint, where there's no rebar, like against the floor, your first leveling course. And this is the this 8.3380. That's the height of the actual height of a block plus the mortar bed. Okay. See, I think that's all there is to the setup of this thing. We're going to get into some numbers now. I priced the materials this week. So this is March 2020, but middle of the month. Okay. This is the math for figuring out how many cubic inches of the wall is actually hollow block. One 5-inch hollow block has a volume of 345.67 cubic inches. Hollow block makers make 85 hollow blocks per bag of cement. I got a guy that works for me that used to make hollow blocks, and he always brags how he can make 92 out of a bag of cement. And I have seen some of the better block makers are making 82, but I don't know. Anyway, 85 hollow blocks times the cubic inches to the block of 345.67. That comes out to 29,381.95 cubic inches. That's all the block that's in that piece of wall, our sample wall. If we divide those cubic inches by 1,728, that's 12 times 12 times 12 is a cubic foot. We come out with 17 cubic foot, 17.00 something. Therefore, one bag of cement is per 17 cubic feet of the aggregate, of the non-cement stuff. This example, we're using for the poured concrete, we're using the mix ratio that was used throughout the house we built. Well, it's almost built. All the heavy structures done. We're into finishing and electrical, and haven't started really well on plumbing yet. But it's well along the way, so we know what the ratios are. We're going to mix 1 bag of cement, 2 bags of sand, and 3 bags of 3/4 inch gravel. The way we fill our bags, and we tested the amount of cement in a cubic foot bag and into a test box, and then we filled that box with sand and put it in a bag and gravel in a bag, and that was our standard from then on. So we tried to make our sand and gravel, this 1, 2, 3 mix. If it was sprayed down with water and kept wet, and we didn't have such a windy site, this would make 8,500 psi concrete. We don't know what it makes. We haven't got test facilities. We know that we have a lot of wind, and that we can't get anybody to water it down, and don't want to have an argument about anything. We're trying to be as stress-free as we can, and there's no use trying to tell somebody that what they've done all their life is wrong. So we use also very good gravel. It's that black obsidian kind of gravel. So it's probably pretty high up on the strength. But we haven't done any slump test. We poured kind of stiff. With an early going, we were doing measured water in 5-gallon buckets, 4 gallons of paint in a 5-gallon bucket. That's what they sell. And we were trying to get equal weight of cement to water. And we found out that we had to add about another quart to that for a 1 bag mix. And it doesn't pour awful easy. You have to shake it with a rod or a vibrator or something to compact it. But if you put too much water, you lose a lot of strength. that the 144-inch long wall with the column is actually 160.3 long. And you're going to find typographical errors all over this because I'm not very good at typing. It's not my strong suit by far. Okay, the column that we're using is 16 inches wide and 7.36 thick. That's a 5-inch block with standard render on either side. And when we grind through this, the volume displaced by the concrete or the hollow blocks is 37,332 divided by 728 per cubic foot is 21.604 cubic feet of hollow block. Here's the length times width times thickness of our 7.362 by 16 inches by 99.208 high column. This column ends at the top of the hollow block. Now this would not be the complete building in either case because the hollow blocks have to have a tie beam across the top. They're not load bearing, so you have to add another piece of poured concrete on top of it with a bunch of rebar in it. It's got stirrups and the long rods, and then there's certain places you can splice them, certain places you can't. But you have to have a beam across the top. For a poured concrete structure, the whole thing is reinforced concrete. I really don't see what adding another a beam on top of a wall that's made out of exactly the same stuff, where that really helps you at all. In our case, we poured a base beam, a wall with a window opening for sure, and sometimes a door opening too, and then a top beam. And we poured our top beam 14 inches wide, 24 tall. It's poured concrete, but we mimicked the standard hollow block construction. If you had both of them sitting in render, they would look exactly the same. But particularly our top beam has got the same stirrups and long rods if it was a standalone beam. So it could carry the building if the poured concrete wall was not underneath of it. I don't know how strong that thing is, but it's plenty strong. Here we have our cubic feet of the column in the hollow block wall. We're going to add this up in a minute now. Don't go away. Height of the wall, thickness of the wall, cubic inches of the poured concrete wall, cubic feet of the poured concrete wall. We have the area filled with hollow blocks. If you're really interested in looking at this and seeing what I'm trying to do here, you can pause a screen and zoom in or out or whatever, and you can go through this math. I'm not trying to hide anything. It's just that I'm trying to get this video shorter than 30 minutes. So we got the cubic feet of the area filled with the hollow blocks, replaced with mortar, render, and filling block core holes. And that comes out to 61 cubic feet and 21.604. I guess that's the render. No, it's the 39 number is the render. The 21.604 is the hollow block. Okay, let's go over to the hang in there. Last column coming up. Okay, price of Portland cement, March 2020. If you're buying 50 bags or more, and you're dealing with the same store pretty regular, it's $2.15. If you don't deal with them real regular, it's about $2.25. Price of sand, 950 pesos a cubic meter, and that's when you buy a 38 cubic meter truck. It's a huge truck, but the advantage to it is it's hydraulic dumping. You tell them where you want it, they tilt it up, and it all comes out. They're on site about 3 minutes while you pay them. This price per cubic meter would be higher if you had the regular 4 or 5 axle truck where they have to unload it with a shovel, because you got a labor cost involved, and they're only going to make about 1 delivery a day because they have to haul it so far. And it's physically exhausting getting all that off the truck, and then it falls around the tires, and you spend about an hour and a half with boards and stones and gravel and all kinds of stuff trying to get the truck to move. So the hydraulic dump is stress-free. Comes in. Of course, we put the last two loads, both of them in the wrong place. I don't know how that happened. We were standing there, and we just had marked out some foundations, and we ended up dumping it on top of them and moved it all with a shovel. Okay, if we take the 950 pesos and we divide it by the number of cubic feet in a cubic meter, we come up with 26.90 pesos per bag. 3/4 inch gravel, same exact reasoning, is 1,200 pesos a cubic meter, same number of cubic feet in it. It's 33.98 pesos to the bag. So now we're going to take and combine this stuff. If we were making mortar or render, we're going to do it for a cubic foot. 4 times the 26.90, that's the sand, comes out to 107.6 pesos. And you mix 4 sand to 1 cement if you're trying to make mortar. So we're going to do 1 times 215. We're going to add those together, the 107 and 215, we're going to get 322.6. When you mix this 4 bag into 1 bag, the cement just sort of goes off into the spaces between the sand, and it doesn't add any volume at all. But best we can tell, it's if you didn't have it, you would have about the same volume, but you could shovel it from one pile to another. It wouldn't be mortar. So we're going to take our 322.6 pesos and divide it by the 4 cubic feet that we get out of that 4 bags in 1 bag. And that comes out to 80.65 pesos to the cubic foot. Now we're going to do concrete. This will make sense in a short while now. 2 times the 26.90, that's 2 times our sand. 3 times our gravel price of 33.98, that's 101.94. And 1 of the bag of cement, same price as above. Total is 370.75 pesos to the cubic foot, or pesos for basically 5 cubic feet. So we take the 370.75 divided by 5, we come out to 74.15 per cubic foot. This is a critical thing to notice. Poured concrete per cubic foot costs less than mortar and render per cubic foot. So every time you take an outpoured concrete and you're putting in render, your price is going up. If you didn't have to pay for the hollow blocks, the price is going up. And that's what turns the tide on this thing is the mix ratio of 4 to 1 and 5 to 1. That's why it comes out the way it does. Okay, who is here? Oh, I think we just did that one. Yeah, we just did that one. Okay, now we're going to do what this sample wall costs in the 2 types of construction. We take our cubic feet of hollow blocks and our cubic feet of mortar and stuff, plus our 108 hollow blocks, and everything times its unit per cubic foot and per block. Add them up, and this wall has, in pesos, 5,656 and 11 centavos. That's for a 12 feet of wall and a column, the same thickness as the render, 16 inches wide. And that's a fairly typical column from what I can tell. A lot of columns are square, but they'll show in your wall. Our columns are square. They all show, but we don't care. It's our house, and that's the way we wanted it to look. Okay, sample wall with poured concrete. A little less complicated. There's 67.67 cubic feet. It costs 74.15 pesos. So it's 5,024 pesos and 69 centavos. The price difference would be the differences in these 2 prices, because that's the total materials in that sample piece of wall. So when we subtract those 2 things, we get a difference in favor of poured concrete of 631.42 pesos for a 12 feet of wall. That's not a deal breaker. I mean, if you can't afford 600 pesos, every time you build 12 feet of wall, you probably not really need to be building a house, because they're terribly expensive time you actually get it all up. We're going to talk about another thing here, because we have another video on slip forming. We did our house with a whole wall section at one time, which is the base tie beam and a wall with a window and the top pie beam and the wall. The walls are 7 inches thick. That's a lot of hydrostatic head. And we basically had 4x8 sheets of plywood. At the end of them, we had a strip like 8 or 9 inches wide, and a 45, a 4x4 cut at a 45, and then a 2-foot form on the that's set out there on the side of that piece that's set on top of the 8-foot sheet, and that made us our 14-inch wide beam on the top, with no leak between the two pieces. I mean, nothing ran out because it was forms on forms. And it gave us a surface on the top to strike it off. And we had a lot of places we could get leverage up there to put tie wire and keep the rebar centered where it was supposed to be. So if I was pouring tall walls, I'd probably use those kind of forms again. But we're trying to show somebody how they can reduce the price of building a house in the Philippines. And also the hollow blocks, apparently, if they pass 500 PSI test, they're sellable. I think the code likes you to have 860 PSI, pounds per square inch, of support value on a hollow block. They don't generally make that. If they're less than 500, you really can't pick them up. If you pick them up and try to turn around or something like that, you'll be holding a little piece of it and the rest of it's falling on your feet. But anyway, the poured concrete, instead of being 500 PSI, it's 8,500. So the big difference is you got a much stronger house. And you haven't got to put render on the walls. We were not real careful about lining our forms up so we have no visible seams. It's totally easy to do that. But we were working with a new crew. We're just starting to basically train them into construction. We had a diver that was worked for a professional, or what do you call it, professional? I guess professional fishing crew. They went down and got conch shells and things off the seafloor and harvested them. And then we had some that made mats like for roofing and things, and some that were farmers that did rice. We didn't have anybody from construction. We had some that had seen construction, but they had never had their hand on a electric drill, screw, gun, miter, saw, chop, saw, drill press, and I don't know how many other things. We have a router, sheet metal shears that are electric, and pretty much everything that anybody would have in the States. We got half of it we bought here and half of it we brought out of my machine shop. I just loaded a couple Balic Bion boxes because back in the day there was no weight limit. Couldn't do that today. Okay, conclusions. Sample wall. If you're doing slip forms, if say you had the forms set ready to pour, you pour them, and then you start filling bags. In the next morning, if you're pouring, you can strip the forms off the previous day's pour, raise them up, bolt them back down, and pour for that day. So you have a pour every day. If you take these forms off early, like 4 hours after you're done with the concrete, be careful because they'll fall on you. They're not stuck to the concrete in the least. For our next pours, we're going to use slip forms because I watched Texas Filipino. That's where I decided I was changing when I saw how easy it was. But you're pouring 4 feet depth, which lets you use a thinner form. He's using, best I can tell from his video, because he hasn't really said, it looks to me like 1/2 inch phenolic board. We've always used 3/4. It's dead flat when you use it. His walls look flat, but I just was a little leery of thinning them down by that much. So we went with a 3/4, but you really can use 1/2 inch. And he lined his forms up, so his seams are almost invisible, and he'll be directly into skim coat. Won't be any render tall in that building. We got some with skim coat just because we thought we'd like to try it. The percentage cheaper of these two kinds of construction is 12.27% cheaper. Wait a minute. No, and that's something. Wait a minute. Let me read here. Oh, okay. If you're doing actual construction, you wouldn't pull a 7.362 thick poured concrete wall. It would generally be a 6-inch wall. Some people are using 4 inches interior wall and 6 inches on the outside. But if you want a 6-inch wall compared to 7.362, you save an additional 12.2% past the 631.42 pesos that is cheaper than the hollow blocks. If you are doing a one-story building and you were putting the made-in-place angle iron metal trusses or metal substructure for a steel roof, there's no need for a top beam on poured concrete. If it makes you feel better, you can pour a top beam all over the whole thing like they do with hollow block. You know, as long as you are structurally sound, you can build anything you want over here, best I can tell. It needs to look like your building permit drawings. That's liable to cause you problems. Let's just take a few seconds here and try to find a good picture. I'm sure there is one. I tell you what, that will look better in 3D. Most everything in this computer is drawn in perspective. See, let's look at the whole page, and then try to find what I was looking at right there. Here we go. Now we'll use that thing that I try not to tangle up with. This is the most complicated part of a slip form. Texas Filipino ends his wall, and then he has a piece that goes around it and makes an actual square column bigger than the wall. But for the purpose of this video, we're trying to show you what you actually have to build a house. And most people get mired down in trying to make a corner with forms, especially when you want reusable forms. So we figured out that we're going to have a 7-inch wall, and we added half the distance of the wall thing to the outer piece and subtracted it from this. So if you take a 4x8 sheet, you cut it one time, and you get the outer phenolic board and the inner phenolic board. And then you have to have a way to bolt them together and to brace them. You can see how the plywood for this one overruns here. And it's got a bolt-up plate. And this one over here, which ends right there, it's got a bolt-up plate. And there's holes through all three pieces. All the holes are the same. All through the whole thing from one end to the other. They're all the same. These holes out here, on every piece of phenolic board, those holes are the same. So you have one hole pattern here, one hole pattern there. They can't be the same because if you put this one up there, it would be trying to go through the center of this brace. So there's two distinct heights of hole patterns, but they're the same through the however many forms you build. They're all interchangeable. I'm not on my mouse pad. That's why this mouse has got a mind of its own. This one is screwed to this phenolic board. This one's got screws in from this, and then the two of them bolt together. And there's holes in this phenolic board for the bolt that goes through that. This bolt head is going to be a blemish on the concrete. We're going to put a piece of duct tape, maybe two strips over it. And we're going to have to fill that with a little bit of render as a dab. But you have to put a dab in these, to make the thickness of the wall in poured concrete, no matter whether you're using our tall forms or these kinds of forms, you take PVC pipe, you cut it, like we use a miter saw, but you can cut it with a hacksaw blade with no frame. We've done that too. That length of you're doing a 7-inch wall. Every place you see one of these holes through the phenolic board, you got a 7-inch piece of pipe, and then you run a piece of threaded rod through it. No threaded rod thinner than 3/8. I would be uncomfortable with 3/8 because it puts enough strain on it. Sometimes the threads upset a little bit, and it's a real miserable thing to get back apart. We use 1/2 inch. It's overkill. You could use 7/16 just fine, but try to find 7/16 rod or bolts that are this long, because you got 7, 8 1/4, 11 1/4, 14 1/4 of stuff to go through, plus a washer and a nut on each side. So you're talking 16 inches. So, and we plan on using any little short pieces of threaded rod we had from anything on the site. Even if it's too long, we'll put them in these just to pour some walls. But if we run short, we're going to buy actual bolts that are the right length to go through 2 pieces of this. Some of these pieces, like we were looking right here, this one is laid flat on the phenolic board, and the one it butts up against, this one is perpendicular, like all the ends have, and all the straight runs of panel will be, standing on edge. The edgewise is stronger than laying it flat. It's the higher section modulus. It's got to do with second moment inertia and stuff like that. Okay. Let's just take a look here at a form that, well, that's not a good place to look. Those forms right there are upside down as far as looking at them. I'll flip them over someplace. Oh, please. Oh, piece of scrap paper I was using and moved. That's why it was acting so awful. We can look at a full-size form here, I thought. Okay, we'll just turn the thing